Good evening here. We're back again a little bit late, still recovering from that 4.5-hour broadcast we did earlier. Clear skies here in Texas, and that's a plane going from Houston to Boston, JetBlue. Thanks to Flight Radar 24, I can see what's going on up there in the sky and see who's laying down the contrails there. So anyway, that's what's going on there, and let me check my levels here, and I think we are set. Let me know if there's any audio problems, because I was kind of busy coming out of that webcast earlier. So, here's the temperature anomaly. This gives us an idea where the air masses are. Warm air mass pretty much from Pennsylvania down to Ohio, southward to Alabama. So this gives you a very good idea where your fronts are. So if you're having trouble, if you're doing a weather analysis and you're not quite sure, this lets you compare things against climatological normals. So St. Louis here, definitely below normal. Lexington, Kentucky, above normal. And when you see that and there's a temperature contrast across that zone, that means you probably have a front between those two locations. So finally, cold air mass covering Texas. Haven't seen that in what seems like months. Cold air coming southward, and some warm air getting started up once again out on the west coast there. Okay, do we have, I guess we don't have high temperature still. I was going to take a quick look, but we can probably see what happened yesterday. Here's some of those temperatures we had yesterday. Lots of 80s. And you can kind of see why we got a lot of that severe weather from Texas all the way to the East Coast. Unseasonably warm air. And not quite as important as moisture when it comes to severe weather, but definitely a contributing factor there. 250 millibar chart showing our jet activity. And we're just seeing a long wave across the central U.S. I'm sorry, not a long wave. This is a short wave here. Large short wave, large scale short wave here. And same scale ridge here. When I was in the Air Force, they went by a term called a major short wave and a minor, or major short wave trough and ridge. And that's what these are right here. Your true short waves are going to be almost unresolvable on a chart like that. They're going to be very small scale. And let me show you an example here. For that, we go to the dynamics chart. And you've probably seen this every evening, because I'm sitting here trying to turn you all into experts. So we bring out some of these tools, and vorticity is one of them. Okay, so here's that trough out over the central U.S., and you can see it's a very large trough. This whole thing is a trough, but you can see embedded in that there's a few small scale waves, like right here over northern Michigan. So that's what a shortwave is, and that right there, shortwave trough right there. And there's probably one here, kind of flattened out, going through that ridge like flow right there. There's a shortwave right there too. And look at the wind flow. You can see that very gentle change in the wind direction there. Now, if you're really good, you can find that not at 250 millibars, but down at 500 and 700. And you would be looking for very carefully, what's the word I'm looking for? You would use a lot of careful consideration what's going on in the data, and you might be able to place short waves where you see a weak wind direction change, like maybe there. I'm just kind of making that up. But it's going to be very difficult to just sit down like what I'm doing here and find short waves. It would require a forecaster that's kind of been watching things, and they might be able to use this in conjunction with satellite and other tools to find exactly where those are. Okay, let's check out the thickness charts. Here we go. Here's the current thickness chart. This is basically a NAM forecast from midday to the current time. And pretty easy to find where that cold front is. And you can use this to refine your surface analysis placement. Not much of a front in the Rocky Mountain regions because they're under anticyclonic flow. And also under a ridge. And then off the west coast, looks like we've got our next frontal system out there. So probably seeing a pattern kind of like that right there. Okay, let's see what's going on the phone. Okay. Let me take a quick look at the chat window. And I'm just checking to make sure that the microphone is on, which is good. And let me try to leave you with a good graphic before I start into the chat itself. So maybe I'll go to Goes East. Let's see here. We'll give you an infrared photo right there. And it doesn't look like it wants to take it, so we'll go to the wider sector there. And let's see here. Animation. And we'll try to take a look at this convection in the Georgia area right there. In fact, hey, I got a better idea. Let's run this back, way back. 30 image loop. And we had a high risk out over this area earlier today. And we're talking about right through here. High risk exactly right there. And of course, a high risk, that means widespread severe weather. And we don't have too many days like that, so this was definitely worth covering. And I jumped in at 2 p.m. and started broadcasting for, ended up being about 4.5 hours there, though. We were kind of watching the weather. And I plan on doing that this spring for any big chase outbreaks or anything interesting like that. So here we go. Here's those thunderstorms. This loop starts at 3 in the morning. So we're seeing overnight showers. Let me run this back and you can... I'll put the time up here so you can check that out too. So 8:45, that's going to be about 3 or 4 in the morning. Activity going on across southern Georgia. And you can see the main Bear Clinic system way out here. So does anybody know how to find the jets and the fronts? Well, the jet is pretty easy to bring through the backside. It's going to be kind of like that right there. And from there, it's either going to go over the top. It may break up like that, or it may actually go directly through the system. And to tell you the truth, I actually forgot the... whether there's any techniques for figuring out whether you have this system here. It's called a Type A system, I believe, and the other is called a Type B. One or the other. I've actually forgotten, but those are basically the two types right there. But more importantly, your fronts are going to be underneath that segment of the jet right there. So Might be looking at something like that right there for the cold front. And then the warm front, that's going to be right there. So you can see these showers are out ahead of the cold front. And further west, we have the occlusion coming back to the cold core low right there. Okay, I'm going to leave this up for just a second while I look through chat, and maybe you all can tell me if this is a warm occlusion or a cold occlusion. Okay. I can't look at chat with those graphics up, so let me just let it go right there. Anyway, you've seen it. If you have any guesses, let me know. And now I'm going through chat. And let's see, I've got Ryan Toomey's. He was here on that afternoon session and now in our nightly webcast at EW is here. Dorothy Tornado, Victor Cabot, and I've still got to get your pictures up. I have been, I know exactly where they are. They're in my email attachments subdirectory, and I've got to fish them out of there, but I am looking forward to putting those on here. Jeremy Mattingly, greetings from New Hampshire. Eddie W. is here. Alexi and Fred Reamer, 5x5. Derek Seymour. Ron Chalfant. Audio sounds good. Joshua Gilbert. Lexi says it's kind of on the cool side in Texas, Central Texas, 64 with a real feel of 62. Ryan says great amount of damage clips, pics and videos from today's activity across Georgia. Michael Burrell's here. Lots of weather there in Georgia. Jason Bach says it could have been worse. Very fortunate for a high risk. Greg Schultz is here. Waiting for a 50-mile-an-hour gust to come into Milwaukee tomorrow. Let's see. Fred Reamer, 700 millibars, has 30-meter interval. So he's mentioning how there's more lines on the 700 millibar chart, and it's easier to find short waves that way. Mike Estwick here, 60 today in Denver. Greg Schultz, 70 in Milwaukee on Sunday. Ryan Toomey says cold occlusion, and that is correct. And Greg says, hope my voice is better. Yeah, thanks. That's kind of weird. It started out at 2 o'clock when we did that broadcast. And I sounded just like Sergeant Highway from that 1980s Clint Eastwood movie, Heartbreak Ridge. But somehow as I went on, eventually I kind of worked it out, and I don't know what happened there. And now I took a break, and now my voice has gone back to crap, so I don't know. I don't understand it. All right, so let's see here. Yeah, cold occlusion on this system. And a very quick way of figuring that out is look at which front your occlusion joins up to. This kind of joins up to the cold front, doesn't it? So it's got characteristics of a cold front. The air is denser on this side than it is on the forward side. So it acts as a cold front. And so we call it a cold occlusion. Now on the British Columbian coast, they get something different called a warm occlusion. Let me see if I can draw this out real quick. Okay. I'm going to use this map of the Northwest Fur Trade. I guess that'll work. Can I get your meteorology forecast along with your destinations for your bales of fur there? Okay, so you have a lot of cold air in the continental regions, British Columbia, and that cold air tends to move out into the Pacific waters. So very cold air coming out in this region right here. The central Pacific Ocean tends to be very warm out in this area here. So when we have these cold fronts coming in from the west, let's say you have a system like that, you eventually get into a situation where the air here is colder than the air here. So the system ends up looking like this. Okay, so there's your occlusion, there's the cold front, then your occluded low would be way up here. I'm sorry, I really screwed that up. Try again. There we go. Probably threw some of you for a loop doing that right there. Okay, there's the low, and this is the warm occlusion. So you can see the dense cold air on this side, kind of acting like a big barrier to the air on the other side. So warm air, warm sector right here, glides up and over. The air here, kind of warm compared to this air, and it glides up and over, same way. So whole thing here acts kind of like a warm front. So let's see, I was just checking out this map right here. Yeah, I was reading some stuff about Fort Astoria this past weekend. I think that's where the Lewis and Clark expedition came out, and they were sitting here waiting for a ship to pick them up, if I remember this correctly. And no ship picked them up, and they had to weather a very brutal winter there at Fort Astoria. And I think that 1811, that was around the time of all that weird volcanic activity. So some pretty unusual weather. And eventually Lewis and Clark gave up and they went back inland. So Fort Astoria, one of the first settlements on the west coast there. Okay, back to the maps. Let's see here. I'm going to go ahead and press on to the... Yeah, let's take a quick look at what's going on in Georgia, because we've had a lot of weather going on out there today. So let's see, change sector, and there we go. So you can see that most of our activity there is basically mesoscale convective complexes. There's three main systems, that one right there, this one, and that one. And you can see that the one that's associated with the cold front, it's going to be these two located right here, and this one is out ahead of the baroclinic system. So cold front just now entering northwest Georgia and eastern Alabama right there. And the warm front well up to the north. And this is just joining up into a large squall line there, moving out into the Atlantic. So that's going to pretty much shut down severe weather potential in the wake of this for the time being, but some more moisture is sneaking back northward up through here into the Atlanta area. So probably still a little bit of a chance for severe this evening there. Depends on how much moisture advection we have back over this cold outflow boundary right there. We can take a look at the instability. There's the cape. This is the surface-based cape, and you can see pretty much zero back through here in the wake of this system. And like I mentioned, the bulk of the moist air is located along the Alabama-Georgia border right there. So the best odds for severe weather, it's going to be on the tail end of that system down here and on the tail end of this one right here. But we're getting to our nocturnal minima, so I'm not too sure we're going to have much else going on tonight. Okay. Let's shift gears and talk about the forecast there. And before I do the GFS, I'm going to start out with a convective model. And you can see we've got this choice of models. We've got global, regional, and convective allowing. And by convective allowing, we're talking about models that have dynamics packages that are equipped to handle convective weather. And we're talking about, the transport of heat upward and downward through buoyancy. And a lot of this here, this regional, this includes the mesoscale models. So we're talking about systems that are out of hydrostatic balance, systems that have a very large vertical depth compared to the horizontal. So, of course, the NAM is the most popular one. That's kind of like the replacement for the old NGM model that was used until the early 00s. And now they use the WRF for this. The WRF NMM core. So there's two main cores of the WRF. The NMM is the INSEP one, and then the other is the ARW. So the ARW, these are research variations of the WRF. And from what I've seen, they seem to be a little bit more accurate for initiating storms and placing them. The only downside is that they're very computationally intensive. So you'd probably be looking at, I'm not sure if that actually stops INSEP or what, but that's just my understanding, is that they do take a lot more time to run. I believe the NMM takes only about 10% of the time of the ARW there. Okay, so we've got a convective model up, don't we? We got the NAM. I'm sorry, yeah, this is the regional model. And I'll go ahead and bring this down to the southeast U.S. Okay, there we go. So you can see the convection out around Georgia. And you can see that this is an 18Z run. We don't have the latest data, so we might want to go to the HRR. Let me just do that real quick. Okay. So the first thing that we ask ourselves is this model initializing close to what the actual conditions are? So for that, we just look at these INSEP charts right here. And remember, we have a big system along the Atlantic coast all the way down to southern Georgia, and then these two systems from Atlanta southwestward, and then this one right here. And if you're comparing model initialization, it can kind of help you to kind of recite out loud where they are. And you notice that I do that sometimes too. Okay, so did it initialize okay? It's 01Z. So here we go. Yeah, there's that system. It's close. It got the bulk of the solid stuff right there. That's pretty close. And then this activity down here, broken, scattered. Yeah, scattered. That's probably right there. And this looks good too. Two main centers, or two main cores right there. Okay. So I think we're off to a good start here. So let's see what our model looks like going forward. There's our cold front coming in from the west right there. So that'll move quickly through the south overnight. So by 6Z, we're going to see probably some elevated forced convection right along this line right here. This does not look like severe weather to me. So basically the cold front is acting like a big wedge as it moves eastward. And then we have the other activity here, kind of losing support and dying off. Looks like the cells down in the what towns are down there? Plant City? I don't know. But this area right here, southwest of Jacksonville, that's filling in pretty good there. So probably maybe a little potential there overnight. Because as you see, we go from this to that. So that's definitely a signal that the convection in that part of Florida will be increasing and becoming more intense. So here comes the front out of Georgia. By daybreak, it's already to the Atlantic coast. Very fast-moving front there. And then things just move on down to Florida. Cold air sweeping in behind. It's going to rapidly clear out the system right there. And you see the 540 decameter thickness line coming south. And that means temperatures in the 30s. It's just kind of a quick rule of thumb there. So things are going to be getting cold for sure. Okay, here's the GFS. Let's check this out and see what our forecast is. By daybreak, here's that system coming through Florida off the Carolinas coast. Looks like the main warm front way up there in the Ontario region right there. Looks like maybe a new frontal system right there in Virginia. And some very strong gradients over the Great Lakes right there. I know we've got a viewer in Milwaukee right there, and looks like we've got a lot of wind overnight right there. Gradient really picks up there on Lake Michigan towards daybreak. And gradient looks even more intense out over the Toronto and London, Sarnia. And some pretty good wraparound of snow and rain all the way down to Ohio there on Thursday night. Okay, you can see a cold core low right there. See that thickness kind of isolated right there, just a big, that's the upper level low right there, kind of hanging back. Cold pool too. The cold pool is the whole reason the upper level low is there. So, and that upper level low, assuming it actually is there, that's going to stack downward towards the surface low like that. And that shows you the rule of thumb. Surface lows that are baroclinic, they will always stack upwards and toward the cold air. And there's the cold air. Going to be a cold day in Ohio on Friday there. High pressure across Texas. Cold air advection on that side and warm air advection on this side. Setting up the lee side trough right there over the high plains. And now we're starting to look at the Pacific for stuff coming in on Friday. So things will be active on the West Coast Friday going into Saturday. I bet you we're going to get some really cool pictures off the GO 16. I'm going to be keeping an eye on that. We're probably going to see some neat stuff out in this area. So Saturday, front will start crossing the Rockies there. And we see it emerge on the other side by Sunday night. And it looks like we may have a chance of convection because we're already up to May, or I'm sorry, might as well be May. We're already up to April, and we've got this long fetch of moisture, and temperatures are probably going to be recovering back up to the 70s, so looks like a possibility here of maybe some thunderstorms. And let me pull up the dew point plot, and we'll see exactly what's going on. Okay, upper air, surface. Yeah, there it is, dew points and wind barbs. Okay, let's see, we're just loading, waiting for the frames to load. And once this comes up, this will give us an idea where the moisture is located. And remember, you might want to keep this in mind as a rule of thumb for as long as we're using these pivotal weather charts. Blue always means 60-degree dew points. Purple means 70. Dark blue means 50. And I'd bet the start of the coloration of green, that probably is 40, I think. Yeah, it's 40. You can see that on the bottom right there. So that's a quick way you can tell what the dew point is. And let's run this forward. Okay, frontal system moves off and up the coast, and then we get up to Friday and then Saturday. And now you see the moisture starting to come northward late Friday night. And remember what the green values mean. The darker green, remember those are 50s dew points. So 50 starting to work up into North Texas here. Lower 40s all the way up to Manitoba. And this is probably the start of the low-level jet here. Strong gradient, and that's pretty much all we need. And now the serious moisture comes up. Here comes the 60s all the way up I-35 to Tulsa. And I-35 doesn't go through Tulsa. So I-44 takes the split right there. Moist air mass gets off the freeway and takes the exit right there. And yeah, 60s all the way up to Tulsa by Saturday afternoon. And now it starts coming up in real force. And I'm going to take a look at the 925 and 850 dew point here. We're going to see how thick this moisture is, how deep it is. So let's see here by Saturday night. 60s dew points already parking itself over Iowa. You can see cyclogenesis coming together in Nebraska, so moisture is just trying to get itself seated here. Then by Sunday morning, good cyclogenesis right there, storm system coming together, and looks like maybe a dry line right through here in the panhandles. And of course a warm front up to the north like that. So we got our moisture axis right here, kind of lined up with a warm front right there. And if you want to plot the thermal axis, you can do that too. And just taking a wag at this, thermal axis is probably going to be back into here. And there's a rule of thumb from the 70s that you plot out the moisture axis and you plot out the thermal axis. And usually the area in between is going to be your severe weather risk area. And normally that's going to be pretty much where all that hits a boundary, which is going to be that warm front right there. So right around Sioux City, that's probably going to have some of the better potential on Sunday. So there we go, cyclogenesis, pressure falls up there in northwest Iowa. 60s dew points all the way up. And we'll have to keep an eye on the dry line too. That's going to be located right there. I'm not too exactly sure where the cold front is, but anyway, that's what we're going to be looking at. Then things push eastward, and this looks like the cold front coming in on Monday evening. Okay, so things start moving around Wednesday and Thursday. We see the moisture feed, 60s and 70s dew points. Now it's taking aim on West Texas. So we're getting these pressure falls out in the Rockies. Also, we've got high pressure It's kind of like a big dome, setting up this pressure gradient like that and pushing the moisture feed right up the Rio Grande. So by Wednesday next week, you see that moisture making it up into the Panhandle, and as we get strong heating on the plains, the edges of it kind of erode here, and you can kind of see that at various times. Like right here, you can see a little bit of erosion, and let's see here. Moisture working its way up into the western Kansas area on Saturday. I'm trying to find out if the dry line is active here. Looks like it really isn't. Just looking at this, I think our dry line is like way out here. So the main moisture axis right here, and now it is taking aim on Nebraska and the Dakotas. So probably a little bit of activity up there for the 15th and 16th, way up north. And we have this other system coming together in the Oklahoma Panhandle. Good triple point here. This looks like a cold front, changing into a warm front right there. And I don't know if we have a cold front there, but the dry line, it's probably a dry line right there. So triple point right up there near, let's see, near north of Woodward. We're talking about late on April 16th on a Sunday. So probably a little bit of chase action up in this area that weekend. And then finally, it looks like we get a good push eastward. We got 70s coming up in Texas on the 19th. And this is interesting. It looks like some upslope flow into the Denver, Cheyenne, Scottsbluff area here. So we probably got a cold front becoming stationary in this area right here. And let's see, I think that's probably about it. We're up to the end of the run, 384 hours out. So anyway, that is the end right there. So, all right, let me take a look at the chat. I don't think I really have talked very much to you guys. Let's see here. Tom Skilling, Victor Cabot says, Tom Skilling, Fermilab's weather presentation on Saturday, viewable on the WGN website, one showing only. Yeah, that WGN, Tom Skilling, that used to be one of my favorite webcasts or weathercasts back in the 80s. Tom Skilling, very good presenter there, and definitely knows his stuff. Dorothy Tornado asks, did you go to the Battery State Park? I don't know if that's to me or somebody else. I've never heard of it. Fun with Tech says, good evening all. Fred Reamer, Cape Disappointment, foggiest place in the U.S. Dorothy Tornado works at Heceta Head Lighthouse in Oregon. Wow, awesome. That's a very unique position. Disappointment is black and white lighthouse. Carl says, I was trying to watch the webcast from the beginning. It showed 4:45:41, but once I clicked, it dropped to about 2 hours. I wonder if that webcast is still rendering on YouTube somewhere. Okay, let's see here. Diane says, I would like to put in my order for a nice, slow, steady 4 to 5 inches, 60 miles southeast of San Antonio for my girls in the field. Well, hope that comes together for sure. In fact, let's take a look at the drought monitor. I don't think we've looked at that in a while. And I know we've gotten some rain in our part of Texas. North Texas hasn't been too bad this time around. So, yeah, it could be a lot worse. And, wow, look at California. They have just completely exited the drought up north. But looks like the drought's settling in once again in Oklahoma. Fortunately, it looks like the storm track is going to be a little bit more oriented in that area. So hopefully Oklahoma will get a little bit of a break here. And, man, not again. I remember Atlanta several years ago, they were dealing with a very bad drought there. Yeah, I hate seeing that happen again. Carl says, I wish we had better run-to-run consistency with the GFS on this next system. I compared the plots, and the 12Z GFS seems to have more consistency with previous runs for Sunday. I am waiting on the 0Z. Consistency would be nice, Fred Reamer. All right. WGN Chasing with the Wind. Yeah, I remember that. That was pretty awesome. 1990s Plainville Tornado Special. All right. Okay, I think we've probably gotten to the end of the line here, so I'm going to take a break here and probably watch some Hell's Kitchen. I'm on season 11. So I'll be checking that out here and relaxing, and hopefully you all have a good evening. And let me get my closing sequence ready. Yep, I think we're all good here. So anyway, hope you all have a good evening, and we'll see you at the usual time tomorrow. Take care.